Okay, so let's go over practice exam. So number one, find eigenvalues. So a equal to -2 and 18 and 8 and 8. Okay, so how do you find the eigenvalues? So we have a determinant of lambda I minus a equal to 0. So let's set up this one. Lambda and then identity matrix in 2 by 2 in that case, right? So this is the 2 by 2. So let's set a 1, 0, 0, 1 minus a equal to -2, 18, 8, 8 equal to 0. Okay, then determinant of lambda minus 2, but then there's a negative, right? So it's a positive 2. And this is a -18. And this is -8. And this is lambda minus 8, right? Okay, so we can find the determinant of 2 by 2, right? So multiply this way. So we have, white blue. Okay, so we have lambda plus 2, lambda minus 8 minus, then we have -18 times -8, right? Now, I need your help. Can you please calculate what is 18 times 8? -8, right? So while you calculate, let me distribute. So we have a lambda square minus 8 lambda plus 2 lambda minus 16 minus, what do you get? This one. So we have a -144. Can you please calculate -16 minus 144? -160. Thank you. So we have a 6 lambda minus 160 equal to 0. Okay, then we can factor out. So that will be lambda, lambda, and we can do -16, +10 equal to 0, right? Okay, this means lambda minus 16 equal to 0, lambda plus 10 equal to 0. So lambda equal to 16 and lambda equal to -10. All right? Those are eigenvalues. Okay, number 2. Okay, so we have to answer. It's given AB plus CD equal to, this one looks like they calculate this way. In this problem, okay? Not every problem is like that, right? So this is a particular problem. So we have, why I'm using blue? So we have A plus D and P plus C. And then the scalar, we have AB, then this will be CA, CB. Okay, now the question said that the first one is vector U, 0 is in U. Okay, let's find out. Let U equal to AB and 0 equal to 0, 0. Then let's add them. Okay, for this problem, we can add this way, right? Only this problem. So there will be A plus 0, B plus 0, which is AB, which is U, right? So, yes. So, let me put in there, okay? And second part, we have U plus V. Then this is R2. Okay, so we know U equal to AB. How about let V equal to CD? Okay, then we have U plus V. Let's check that. Check it out. Yeah. So U equal to AB plus V equal to CD. Now we can calculate this way, right? By this given the information in the beginning. So we have A plus D. Then we have B plus C. So there will be same as we can express U plus V, right? Because AB come from vector U, DC come from vector V, right? Okay. Yes. Since, okay. Third one, is it U plus V equal to V plus U? Okay. So U plus V, we can use that. U plus V equal to A plus D, B plus C from the second one, right? How about we check V plus U? Okay, V is CD and U is AB. There will be, we add this way. So there will be C plus B, D plus A. Okay, so we don't get the same, right? We must get the same format as A plus D, B plus C, right? So it's now equal to A plus D, B plus C. So let me put the not equal to, right? We know that not equal to V, I'm sorry, V, vector V plus vector U. So no, since, okay. Okay, let's do, any question? Let's move on number 3. Number 3. Number 3. Okay, proof. We have 12, negative 12 belongs to the span of the set of negative 1, negative 4, and 2, negative 4, by showing it's a linear combination. Let's make it short. Those two vectors. Okay, so we have to answer box, blank box, 12, negative 12. Yeah. Okay, so we can just using decimals, right? Because generally we can use linear combination is the form. Let's say that this is y. This is how do we make it? V1, V2. So we can express linear combination y equal to a v sub 1 plus b v sub 2, right? Okay, so this, our goal is we need to find such a coefficient a and b, right? Okay, I'm giving you permission to use decimals because this is the end of the semester, right? So decimals, we can do that. So -1, -4, 2, -4. And there will be AB equal to 12, -12, right? So there will be -1, 2, -4, -4, 12, -12. Can you please calculate? So we have 1, 0, -2. And 0, 1, +5. Okay, so this means A, B, right? So A equal to -2. This means B equal to +5, right? Okay, so then the answer is okay. So -2 and +5. Okay. All right. Any question? Number 4. So are the vector linearly dependent or independent, right? So we went over last time. So linearly dependent, then we can express zero vector. The linearly dependent contains zero vector. Because this one we can express as a linear combination, but then all coefficient, not all coefficients are zeros, right? But not all coefficients C sub I are zeros. Okay, this one also we can express non-trivial solution, right? And we can express multiple of the other, right? Okay, they are related to each other, right? Because zero vector is related linear combination, but not all C sub I are zeros. Since not all C sub I are zeros, we can set up one vectors are zeros vector to make the other side is 0, 0, 0. Yeah, okay. And we set up other side is 0, 0, 0, but then non-trivial solution, so we can have unique solution or infinitely many solution, right? So we have to set up this way. And multiple of the other vectors is similar with linear combination expression, right? Okay, so the vectors, given vectors, we have -1, -15, 3, and 0, 1, 0, and 6, 99, and 18. Is it, can you see well? Maybe make it a little bit bigger. So 6, 99, 18. Okay, so we can find the solution, right? So let's say using decimals. So -1, -15, 3, 0, 1, 0, 6, 99, 18. So there will be A, B, C, or we can express x of 1, x of 2, x of 3, right? 0, 0, 0. Okay, can you please give it to me using only this one? And reduce the row echelon form. Okay, so let us go to decimals. Okay, so A, so we have a -1, 0, +6, and -15, and +1, and 99, and 3, 0, and +18. Oops. And reduce the row echelon form. Oh, that's weird. Huh. Wait a minute. Sorry about that. There is a -99. Oh my gosh. This is so funny. Okay, I'm very sorry. So this is a +1. Oh my gosh. Okay, now, now what I got? Oh my gosh. So sorry about that. So it's this one. Okay, so let's go back. So 106, 01, -9, 0, 0, 0. Yeah, let's go back there. So this is -9. Okay, so this means A equal to A, B, C, right? Hold on a second. So A plus, how about this? So A plus 6C equal to 0. B minus 9C equal to 0. 0 equal to 0, which is true statement, right? So which one is the free variable? A, B, C. Which one is the free variable? C. Thank you. That means infinitely many solutions, right? So we can conclude, thank you, in the chat. So we can conclude therefore linearly dependent, right? Because there is non-trivial solution, right? Okay. All right. Number 5, what about the subspace? Decide if it's a subspace of R2. Okay, so for the first one, the set of points where x is greater or equal to 0, right? So this means we have x, y, right? Order pair, so take the only x, which is positive or equal to 0, right? Okay, then subspace, it must be contained 0 vector, right? 0 vector, and must be closed under addition, and must be closed under scalar multiplication. Okay, so check it out. First one. So we knew, we know 0, 0 is in R2, right? Yeah. And the first one, right? So I say that this means only the first one, x coordinate, right? So this one, we take that, only the first one, x. So 0. And then I am following the definition here. 0 greater or equal to 0. So 0 vector is in the set. What's the set? Set is, in the case, x is greater or equal to 0. Okay? All right. Secondly, we need to show that clause on the addition. So let vector u equal to x sub 1, y sub 1, vector notation. And or just order pair, huh? We just say that. And v equal to order pair, which is x sub 2, y sub 2. Okay. And we knew for the set x sub 1 greater or equal to 0, and then x sub 2 greater or equal to 0. So x sub 1 plus x sub 2, since this is greater or equal to 0, and this is also greater or equal to 0, right? We add together also greater or equal to 0. So we say that it's closed under the addition. Third one, if c is greater or equal to 0, then we can say that c x sub 1 also greater or equal to 0 because x sub 1 is greater or equal to 0, right? But if we c is less than 0, c times x sub 1 less than 0 because c is negative, right? And then this is a positive, multiply with a negative and positive is negative, right? So thus it's not closed under the scalar multiplication. So we say that not subspace. So this is not subspace of R2. Okay, second one. The set of points where x equal to 2. So x equal to 2 means vertical line, right? Which is x equal to 2, right? Okay. In that case, there is no 0, 0, right? This is 0, 0. Yeah. So 0 vector is not in there. This is not a subspace of R2 since the 0 vector is not in the set. Set in the case is x equal to 2. All right. How about C, y equal to 0? The set of points where y equal to 0. So y equal to 0 means horizontal line. So there is x, y. So here, right? So y equal to 0. Okay. We can see that 0, 0 in the set, right? 0, 0, 0 vector in the set, which is y equal to 0 is the set. Number 2, u equal to, this is the form of x sub 1, 0, because y sub 1 equal to 0, right? And vector v equal to x sub 2 equal to 0, because this is a y sub 2 equal to 0. Make sense? Okay, good. All right, so then u plus v, which is x sub 1 plus x sub 2, 0 plus 0, which is x sub 1 plus x sub 2, 0. So then this is the form of y equal to 0, right? So it's closed under the addition. So this is y. Yeah, y equal to 0. Okay, number 3. Scalar multiplication. So let's C equal to any number. And then C u, which is C x sub 1, 0. That is C x sub 1, then 0, right? So this is a form of y equal to 0. So this is also closed under the scalar multiplication. So thus it's a subspace of R2. Okay, now your turn. So D is dog, y equal to 3. So I'm really getting cat too.
Does not contain a 0 vector.
Hold on 1 second.
Okay.
Where y equal to 3. You answer this one? Very good. In the set of points where y is greater than equal to 0, right? So he said that the 0 vector is not in there, right? So because same concept with x equal to 2, right? So 0, no. Subspace of R2 since 0 vector is not in the set. Okay, how about this one? Try. Right? So this is from the first problem. So this means that, right? So this means that, and we can set up y sub 1, y sub 2, y sub 1, y sub 2, and we can change that. Y sub 1, y sub, yeah. Okay, very good. Thank you so much for participating. Okay. Number 6. They say that this is the base. this is not base. This is not base. Okay. Y is the set. So we have negative 35, negative 67, 0, and 205, 113, 0, and 209, 630, 0, not A basis. What do you mean?
So since the Z component is 0, they're all in the same plane, so they're linearly dependent.
Ooh. Select all, then apply. So your classmate say that this is linearly dependent? Okay, thank you very much. So what is the basis? Basis? What's the definition of a basis? The vectors must be linearly independent, right? What else? The spanning set. Linear combination, spanning set, right? Yes. Spanning set means we can express as linear combination. Very good. Okay. So then span of vectors. How about that? Okay. So linearly dependent and then this is not basis, then we can say that not span, right? Very good. Spanning set. Okay. So the last question, we have only 7 minutes, 6 minutes left. Okay. Number 7, diagonalize. So we have the matrix 0, 0, negative 1, 0, 0, negative 4, 0, 0, negative 1. Okay, so let's say that this is A. We want to find P, the inverse of P, all right? Okay, so we have you can find finding this non-trivial solution. Okay, so we have determinant of lambda I minus a equal to 0. So we have to, we want to find lambda first. Okay, so determinant of lambda 3 by 3, so 1, 0, 0, 0, 1, 0, 0, 0, 1. Minus A, which is 0, 0, negative 1, 0, 0, negative 4, 0, 0, negative 1, equal to 0. Okay, so please correct me if I make a mistake. So determinant of lambda and 0, positive 1, right? 0, lambda, positive 4, 0, 0, lambda, plus 1. Yes? Okay. Thank you. All right. So there will be, let's do using 3 by 3. So plus, minus, plus. Yeah. So there will be determinant. So lambda. So lambda 4, 0, lambda plus 1, minus 0, right? So everything is 0, yeah? Plus 1, 1, so 0, lambda, 0, 0. Yes? Okay, so there will be, we multiply this way, right? So lambda times lambda plus 1 minus 0. And multiply this way. So we have plus 0 minus lambda equal to about 0, yeah? Okay, so thank you so much. So lambda, we distribute lambda square plus lambda minus lambda equal to 0. So there will be distribute lambda cube plus lambda square minus lambda equal to 0. Okay, so you can factor out. So lambda equal to 0. But then this one you can use x equal quadratic formula, right? X equal to negative b plus minus square root of b squared minus 4ac over 2a. So there will be negative 1 plus minus 1 minus 4 times 1 times negative 1 all over 2. So I get negative 1 plus minus square root of 5 over 2. So we get two answers. So one is positive, one is negative. All right. So I can show you decimals the easy way, right? So lambda cube, so x to the third power plus x squared and minus x. So we have a 0, 0, 0. Okay, this is a more easier way. because I don't want to get suffered by algebra, right? But this is working too. Some of you want to know algebraically. Okay, now the D, we can find the D. So lambda 1, lambda 2, lambda 3, and the rest is 0. Or we can check later with D equal to inverse of P A times the matrix P, all right? Okay, step 2. Find X eigenvectors. X cannot be equal to 0, right? Okay, so for lambda equal to 0, so lambda I minus a x equal to 0, right? Okay, for lambda equal to 0, so we have 0. Everything is 0, right? So minus a is this, copy? And x of 1, x of 2, x of 3 equal to 0, 0. Yeah. Okay. So we have 0, 0, positive 1, 0, 0, positive 4, 0, 0, positive 1, right? Okay. Now, can you please use decimals? In the decimals, we can omit, right? Can you please find out? Reduce the row echelon form. So we have 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, thank you, Robert, for pointing out. So this is 0 minus 0, because this one is 0, right? So, okay, 0. Then this is 0, this is 0. Then we get, let's do everything. Okay, so that will be
Yeah, so multiply it out, right? So then you get lambda cubed plus lambda cubed plus lambda squared. Well, yeah, that works too, I guess, that way, yeah. So
so
yeah, lambda cubed.
maybe we can take it out. 1, so x plus 1, yeah?
Yeah, so -1 and 0, yeah, exactly.
So x squared equal to not x, lambda equal to 0, so lambda equal to 0, and lambda plus 1 equal to 0, lambda equal to -1. Yes?
Yeah.
Okay, then
Where did you get the 1 though?
1?
There's no 1 minus 1.
Oh, sorry. I thought you said -1, 0, 1.
Yeah, -1, 0, 0 are the 3 roots.
Okay, so I factor out the x one more time. I mean the lambda, because instead of distribute, I wanted to factor out. That's why we have a squared. Make sense?
Yeah.
Yep.
Okay, now, so you want to make lambda equal to -1, 0, 0. That's good. It's okay. Lambda 1 equal to -1, lambda 2 equal to 0, lambda 3 equal to 0. Okay, so the so that would be -1, 0, 0, 0, 0, 0, 0, 0, 0. All right. Let's do it. So lambda for lambda equal to -1. So -1, 1, 0, 0, 0, 1, 0, 0, 0, 1 minus a was here. How about that? Oh, earthquake. Did you feel? Who lives in Oakland? Did you feel? Earthquake? Okay. So sorry. So we have, let me do it one step. So it's -1 there. Please correct me if I make a mistake. 0 and +1 and 0, -1, -1 and +4. Yeah. 0, 0, -1 plus 1 is 0. Yeah. Please correct me if I make a mistake. Okay. So that's most. Yes. What do you get? One, 0, -1, 0, 1, -4, 0, 0, 0. So there will be x of 1, x of 2, x of 3. So 0, 0, 0. So there will be x minus x of 3 equal to 0, x of 2 minus 4, x of 3 equal to 0, and 0 equal to 0, true statement, right? Okay, so which one is free? X of 3 is free. Okay, we can set up anything. So let's say that let x of 3 equal to 1, then x of 1. What's the x of 1 will be? X of 1. X of 1. What do you get the x of 1? It's 1. Thank you, Robert. Okay, so we get, this is 4. Then what's the x of 2? X of 2 equal to 4. Okay, so we have x of 1 equal to 1, x of 2 equal to 4, x of 3 equal to 1. So that is x of 1, x of 2, x of 3 equal to 1, 4, positive 1. Yeah. Okay. How about lambda equal to 0, right? So we, or lambda equal to 0. So same processing like this one, right? So lambda I equal to minus ax equal to 0. So the first term is 0. This is a, let me copy this one. Okay. Okay, so didn't we do this one earlier? So we have positive, right? 0, 0, positive 1, 0, 0, positive 4, 0, 0, positive 1. And we have x of 1, x of 2, x of 3. And we have a 0, 0, 0, right? Okay, that's most. You just the row echelon form. So we have a 0, 0, 1, 0, 0, 4, 0, 0, 1, 0, 0, 0. Yeah, thank you. So we have a 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. So didn't we do this one earlier? So that means x of 3 equal to 0. Yes? But then we cannot have eigenvector as 0. Right? Okay, so we have 0 equal to 0, which is a true statement, right? Okay, so we pick anything for x of 1, x of 2, since we have x of 3 equal to 0, right? So let's say x of 1, so your classmate Robert picked the x of 1 equal to 0, x of 2 equal to, okay, very good. 1, x of 3 equal to 0. So it's very good. X of 1, x of 2, x of 3, 0, 1, 0. So we don't have all the eigenvectors 0, right? So this is very good, very clever. Okay. How about second one? The third lambda, yeah? Do again? Okay. So we have lambda equal to 0. Very good. Yeah. Okay. So this is the same, right? Because we were going to use the same concept, right? So we get same processing. Yeah, you can pick whatever. Yes. So what do you want to pick? 0, 1, 2? No, x of 3 equal to 0. So you want to pick 0, 1, 0 again? That's fine too. Yeah, you can pick whatever you like. So x of 1 equal to 0, x of 2 equal to 1, x of 3 equal to 0. But we have to keep the x of 3 equal to 0, right? Yeah. So any random works. Any random works. So we have x of 1, x of 2, x of 3. We have 0, 1, 0. Okay, so P will be the x eigenvector. So that will be, okay, first one, we have 1, 4, 1. Copy. Second one, we have this one. Copy. And third one, copy. So this is P. Okay, inverse of P, can you please use the decimals? Well, step 4. Step 2. Step 3. Step 3. Step 4. Decimals, please. What? Oh, Melinda, why you make a mistake? Where? So you can use decimals. Inverse of P. Okay, so doesn't work? That's good idea too. 140. Well, I'm sorry, 141. Let me do it. Okay, so let's check the decimals. So we have 1, 4, 1, 0, 1, 0, 0, 1, 0. Okay, so inverse of that. Oh, okay. Yeah, so we have to change the number because the third one does not work. That's good to know, right? Very good. You guys so clever. Okay, so this is not working. So pick different number, change that. Yeah, so we have to have something, not all inverse, right? In the 2 by 2, the determinant is not equal to 0, right? Oh, no battery. I am very sorry. 1 second, please. So if the inverse does not work, we have to change the number. Not all matrix invertible, right? That's good to know. Okay, 1, 2. Which one is working? Which number is working? One, 2, 0, okay? One, 2, 0. Change that. 1, 2, 0. 1, 2, 0. 1, 2, 0. So if you do that, can you please give it to me? Inverse of? Thank you, Robert. So that will be 0, 0, 1, -2, 1, -2, 1, 0, -1. Okay. So for summarize, P equal to that And we have the diagonal matrix. So this is the one. This is D. And inverse. Okay. Okay, so let's check that. Can you please check that? A equal to, with the decimals. A equal to P, the inverse of P. Yeah? So that is A. A equal to this. Copy. Then P. Okay. And the and inverse, yeah. And inverse. Did you check that? Okay, very good. So, yes. Okay, so let's go back. Note, if we can't find inverse, then the number should be changed. Okay, thank you confirming, Linda.